Hello, in this presentation I will demonstrate how to run a one sample t-test using the IBM SPSS statistics software. In this file I have 40 observations representing 40 individuals, 40 students actually, and their test scores are on test 1 and test 2. Let's say that, for instance, I would like to know whether students' test scores on test 2 are significantly higher than 70. Let's say that maybe 70 represents a cutoff value, and I know that if the average score is higher than 70, then I know that students have reached a mastery level. They met the objectives for this assessment, and I can move on with instruction. Otherwise, I may need to do some additional teaching. So, based on this question, my alternative hypothesis is one-sided, right? Because I want to know if the average score is higher than 70, not just different than 70. So to run the one sample t-test, I go to the Analyze menu and then click on Compare Means and Proportions, and then select the one sample t-test. On the left side, I get all the variables in my dataset. From here, I select test 2, and I'm moving this variable in the test variables area. In the test value field, I have to specify the value that I test the sample mean against. So in my case, this value is 70. If, for instance, I want to compare my sample mean to a national average, then I would type the national average here. But in my case, I want to use the value 70. So I'm going to click OK. In my output window, I get the results from the one sample t-test. First, I get a very simple table of descriptive statistics. I can see the number of observations, the sample mean, which is 78, standard deviation, and the standard error. I can already tell that the sample mean is higher than 70, right? But I don't know yet if this difference is statistically significant. For that, I need to look at the results of the one sample t-test, which is the second table. On top of this table, I can see that the test value was 70. This is the value that was stated in the null hypothesis, right? The null hypothesis in this case was that the sample mean is actually equal to 70, and the alternative was that the test value was higher than 70. The results of the test statistic, the results of the t-test are reported in this row here. The t-test statistic is 5.26. I can already tell that this is a pretty high value. The degrees of freedom was 39, which is the sample size minus 1. And then in the next two columns, I get the p-values, the one-sided p-value and the two-sided p-value. So for a one-sided alternative hypothesis, you use this one-sided p-value, and if the alternative hypothesis is two-sided, then you use the two-sided p-value. In our case, the alternative hypothesis was one-sided, so we need to report the one-sided p-value. They both have the same value in this case, but sometimes they differ. So it's important to know which p-value to select. The p-value, as you can see, is very, very small, is less than 0.001. This means that if the null hypothesis is true, so if the sample mean were actually equal to 70, there would be only a 0.1% of obtaining a sample that has a mean of 78.17. This is a very low probability, and it's lower than the significance level of the test, which is 0.05. This is what we typically use in social sciences and educational research. And because the p-value is lower than 0.05, I can say that the results of the one sample t-test are statistically significant, and that the sample mean is significantly higher than 70. So I can say that yes, students have made enough progress. The average score is at the mastery level, so I can move on with instruction. Now, another piece of information that is very helpful here is the result of are the effect sizes, which is another test that follows after the t-test if the results are significant. And from here, we can look at, for instance, at Cohen's d coefficient, which has a value of 0.832 in our case. Usually, Cohen's d coefficients that are of zero 0.8 or higher or indicate a large effect size. This means that the results of the test are not only statistically significant but also practically significant. So they make an impact in practice. It's not just a small difference. So this is how to run and how to interpret the results of a one sample t-test. Um, I just want to add something else. If the Cohen's d coefficient is zero 0.2 or smaller, we can say that the results have a very small effect size. If this coefficient or the point estimate is around 0.5, we can say that there's a medium effect size. But if effect sizes are of 0.8 or larger, we can say that there's a large effect size. Again, this is how to run and how to interpret the results of one sample t-test using the IBM SPSS statistics software.